Hello, dear learner. I, Mr. Sri Krishna from Delonic Society's Baramati College of Pharmacy, Barampur, Baramati, welcomes you in the session of Indicator Theory, which is a part of acid-base type of titration. Learning outcome of today's presentation is, after completion of this topic, my student should able to summarize theories of indicator, discuss Ostwald theory, discuss Quinonoid theory, and design universal and mixed type of indicators. So now here is a time to think and reflect, that is reflection spot. So pause this video and write down the question in your notebook. Did you know composition of universal indicator? If you don't, then you need to discuss this topic thoroughly. So moving forward towards the theory of indicators. An indicator is a substance which is used to determine the end point in a titration. Actually, universal is an auxiliary indicator is an auxiliary substance which is used to identify whether the reaction is completed or not. In acid-base type of titration, the organic substances such as weak acid or weak bases are generally used as indicators. They change their color with a certain pH range. The color change and the pH range of some common indicators are tabulated here. For example, methyl orange is responsible to change the color of solution from pink to yellow when the pH range is around 3.2 to 4.5, such as like this methyl red, which is responsible to change the color of solution from red to yellow when pH ranges from 4.4 to 6.5. Then litmus, having a pH range 5.5 to 7.5 and responsible to change the color of solution from red to blue. Then phenol red, which is responsible to change the color of solution from yellow to red when the pH range is ranging from 6.8 to 8.4. And phenolphthalein is responsible to change the colorless solution to the faint pink color when the pH ranges from 8.3 to 10.5. These are the few examples. Now, two theories of indicator, two theories have been proposed to explain the change of color of acid-base indicator with change in pH. And that theories are, first is the Ostwald's theory, then second one is the Quinonoid theory. So here we will discuss each theory one after one. So moving towards Ostwald's theory. According to this theory, the color change is due to ionization of the acid-base indicator. The unionized form has different color than the ionized form. The ionization of the indicator is largely affected in acids and bases, as it is either a weak acid or a weak base. In case the indicator is a weak acid, its ionization is very much low in acids due to common H+ ions, while it is fairly ionized in alkalis. Similarly, if the indicator is a weak base, its ionization is large in acids and low in alkalis due to common OH- ions. Now, considering two important indicators, One is phenolphthalein, which is a weak acid, and methyl orange, which is a weak base. The Ostwald theory can be illustrated as follows. Phenolphthalein, it can be represented as HPH. It ionizes in solution to a small extent as HPH gives H plus pH minus. That means initially when phenolphthalein having a colorless solution which will turns to the faint pink color after ionization. That means here is Ostwald's statement is true. Applying law of mass action to the above equation, K is equal to concentration of H plus into pH minus divided by concentration of HPH. So this is all about the Ostwald's indicator theory. Now the second important theory for indicator is Quinonoid theory. In this Quinonoid theory, according to this theory, the acid-base indicator exists in two tautomeric forms having different structures. Two forms are in equilibrium. One form is termed benzenoid form and the other is termed as quinonoid form. The two forms have different colors. The color change is due to the interconversion of one tautomeric form into another. One form mainly exists in acidic medium and the other in alkaline medium. Thus, during titration, the medium changes from acidic to alkaline or vice versa. The change in pH converts one tautomeric form into another and thus the color change occurs. For example, phenolphthalein has benzenoid form in acidic medium and thus it is colorless, while it has quinonoid form in alkaline medium which has pink in color. Like this, again here is an separate example, methyl orange. Methyl orange has quinonoid form in acidic solution and benzenoid form in alkaline solution. The color of benzenoid form is yellow while that of quinonoid form is red. Now the next type of indicator is universal indicator. The color changes can be produced over a considerable range of pH by mixing certain indicators. These are termed as universal or multiple range indicators. These are generally used to determine the pH of a solution by colorimetric method rather than in quantitative titration. A universal indicator can be prepared by mixing methyl red and thymol blue indicator. This mixture undergoes color change at various pH. At pH 4, color change will be the red. Then at pH 5, color will be the orange. At pH 6, it's rose yellow. At pH 7, it's yellow. At pH 8, it's green. And at pH 10, the color changes blue-green. A universal indicator is a solution that contains a mixture of indicators, often phenolphthalein, methyl red and bromothymol blue. Identification of an approximate pH is obtained by addition of several drops of universal indicator to a solution. Red color indicates a strong acid in the range of 1 to 4, while a weak acid has an orange color. In a neutral solution, the color turns yellow, then green. The purple indicates a strong base above pH 11, while weak base exhibits a bluish tint. Now, the another type of indicator is mixed indicator. In this mixed indicator, which is used for those experiments which are to be conducted in a very narrow pH range, thus requiring very sharp change in color. These indicators are prepared by mixing suitable indicators whose pK value are very close to each other, such that overlapping colors are complementary at an intermediate pH. For example, one part of methyl red that is 0.1% solution in ethanol plus 1 part of methylene blue. 0.1% solution of in ethanol is a mixture of mixed indicator which is responsible to the change in color from violet blue when solution is acidic to green when solution is alkaline. Color change of a single indicator can be improvised by addition of dye stuff which is pH sensitive. This is done so that the mixture, that is single indicator plus dye stuff, produces a color complementary to the color of the indicator. For example, when methyl orange 10 gram methyl orange is mixed with 1.4 gram of dye stuff, that is xylene cyanol, in 500 ml of 50% ethanol, this particular mixed indicator is responsible to change in color from alkaline to acidic, that is from green to grey to the magenta. Now the last type of indicator is fluorescent indicator. These indicators exhibit fluorescence at the equivalence point. They are generally used when the solution undergoing titration are colored or turbid, and they help to avoid any interference between the endpoint and the color of the metal titrant complex. For example, alpha naphthylamine, then mixture of thymol blue and phenolphthalein are the examples of fluorescent indicator. So here is all about the indicators and types of indicators. So credit of this presentation is special thanks to all the people who made and released these awesome resources for free. And if you have any questions or any doubt, you can find me at my email address and at my contact number. So thanks and thank you very much.